This is a problem about calculating the transverse velocity of a string element as a wave propagates through along a string. So as I discussed in the lecture, if I have a string and a wave that propagates in that string, like so, I can consider a string element with mass dm and length dx, and this string element oscillates vertically in a simple harmonic motion, and the velocity of motion of this string element is the transverse velocity u. So this problem is about finding the transverse velocity of such string element when we know the wave form described with an equation. In this case, that is the equation. So y of x and t is equal to 0.00327 meters times sine of 72.1 x minus 2.72 t. And of course, omega, which is 72.1, is in radians per meter. And I'm sorry, this is k, that's radians per meter. And omega is 2.72 radians per second. So let's put those on the side here. So the wave number k is equal to 72.1 radians per meter, and omega, the angular frequency, is 2.72 radians per second. So we want to find the transverse velocity, and more specifically the value of the transverse velocity when x is equal to 22.5 centimeters and the time is 18.9 seconds. So what is the meaning of those two quantities? Well, so this plot is the wave function as a function of position and time, so y versus t. And so the x component tells us where along the waveform this mass element dm is located, and then the time dependence tells us where is this mass element located during its simple harmonic oscillation vertically up and down. So the x component of the function here, one more time, tells us where is the mass element located, and then the time dependence tells us where along the oscillation the string element is. So I'm repeating these things multiple times because they are like completely new concepts, and I just want to you guys to hear them as many times as possible to embed them in your minds, that's what the meaning of those two dependencies are. So by definition, the transverse velocity is the time derivative of the wave function. However, since the wave function depends on x and t, and I want to take the derivative with respect to time only, I am writing the derivative in a slightly different way, and this is known as partial derivative. So d dt is known as partial derivative. So this only means that the derivation is done with respect to one of the variables and not both. And so in this case, that will be the time variable. So taking the time derivative of the general form of the wave function ym ym sine of kx minus omega t gives me minus omega times ym cosine of kx minus omega t. So this is the general expression for the transverse velocity. And now I can replace the numbers that I have in the exact form of the function provided in the problem statement in this expression to find what the transverse velocity of a string element is. So substituting the values for omega, ym, the wave number k, the position x, and the time t in the expression for the transverse velocity, calculating the result, I get 0.072 meters per second or 7.2 millimeters per second. So this is the transverse velocity of a string element. So if this is the string element here, the m, is oscillating up and down with 7.2 millimeters per second. I can also calculate the acceleration with which the string element is moving vertically up or down, and that will be the transverse acceleration. So by definition, the acceleration is simply the time derivative of the velocity. So let's call the transverse acceleration ay, since the motion is in y direction. So that will be, again, the partial derivative of the transverse velocity with respect to time. So this will be d dt, let's fix that a little bit, d dt of minus omega ym cosine of kx minus omega t. So after the derivative, I end up with the transverse acceleration being equal to minus omega squared ym times sine of kx minus omega t. And now I will substitute the values for k, omega, x, and the time. So the expression becomes this, and when you calculate it, you should get negative 0.0142 meters per second squared, or minus 14.2 millimeters per second squared. So this is the acceleration of with which this string element is moving.